on the problems of the day? $24. Is that the one that says find the inverse of this rational function? Am I on a worksheet or bookwork? There we go. 24, you said? John invests $2,300 in a savings account with 6% interest rate compounded annually. How long will it take until the money is $41.50? Okay, so we remember the formulas for exponential models are more than just PERT. We have lots of different models depending on the situation, and so we might do well to remember, in addition to A equals P e to the RT, or its variance like Q equals Q sub O e to the KT, we could also have something like A equals P 1 plus or minus R to the T. This is for annual growth, or, I want to say decay, but really I only ever seem to use it in depreciation. And then we have our compound interest formula. A equals P 1 plus R over N raised to the NT, where we're compounding N times per year. Okay, so I think I want to use this one. And I know that there's 6% interest. I know the original amount is $2,300, and we want to end up with $41.50. Do you need me to go further? Okay. Any other questions? Yes, ma'am. 23. 23 says the half-life of phosphorus 32 is 14 days. Oh, okay. Okay, you said, I'm sorry, which one? 23. Yeah. Because you've got to do three things with it, right? You've got to first build the inverse, which takes time. Then you're supposed to verify, which means you have to plug F into F inverse and F inverse into F, and these also take time. So I will do some of this and leave some of it for you. F of x in number 23 is 2x plus 1 over x plus 3. My understanding of making an inverse, since this isn't a word problem, is to switch the x's and y's. Good so far? Okay, clear out the fraction. Y plus 3, y plus 3. So on the right side, these cancel. On the left side, I want to do some distributing. xy plus 3x equals 2y plus 1. And what am I solving for? Am I solving for x or solving for y? Switch the x's and y's and solve for. So I want to get y by itself. So I got y's right now on both sides. I'm going to move all the y's to one side and the not y stuff to the other side. So xy minus 2y equals 1 minus 3x. And then I notice since I have all these y's over here, I could factor a y out. And to get the y by itself, I'm going to divide both sides by x minus 2. And so I get y equals f inverse of x equals 1 minus 3x over x minus 2. Any questions about building the inverse? Yes, please. Of course it does, because all the signs are flipped. When all the signs are flipped, they're identical. Yeah. Okay. Any questions so far? So now we have to do f of f inverse and f inverse of f. I'll do one of those. F of x to x plus 1 over x plus 3 and f inverse. And Sam, that happens when I chose to move all the y's over here, but you chose to move all the y's over there. Yep. 1 minus 3x, x minus 2. Okay, so which one do you want to do first, f of f inverse or f inverse of f? F of f inverse. And what are we supposed to get when we do f of f inverse of x? X. So I'm going to take this one, and I'm going to plug this in for each of the x's of f of x. So I've got 2 times 1 minus 3x over x minus 2 plus 1. And I've got 1 minus 3x over x minus 2 plus 3. Now, we could go about the process of making a common denominator on top and then making a common denominator on the bottom and doing some flipping and multiplying. But I like this method more. Notice how these already have the same common denominator? Well, I'm going to multiply here by this over itself. So I'm just going to multiply here by a form of 1. And in the process of doing that multiplication, I actually have to distribute this to each of these. So when I distribute this over here, it knocks out my denominator, and I'm just left with, anyone else need Ben's list? Okay. So I'm just going to be left with 2, 1 minus 3x plus 1 times x minus 2. Now what about on the bottom? On the bottom I have the same sort of distributing situation. This times this will give me 3x minus 2. And this times over here, these will cancel, and I'll have 1 minus 3x. So I'm going to do some distributing on top and combining like terms, and I'm going to do some distributing on the bottom and combining like terms. And so that's going to give me 2 minus 6x plus x minus 2 over 1 minus 3x plus 3x minus 6. 2 minus 2, those cancel. Minus 6x plus x is minus 5x on top. And on the bottom, minus 3x and 3x cancel. 1 minus 6 on the bottom is negative 5. These cancel, leaving me x and smiley face. Okay? So we just did f of f inverse. You'll still do f inverse of f. Remember, when you're called upon to verify that two functions are inverses, someone's eraser's on the ground, you need to do both compositions and show that both of them yield x. Anything else? Cool. Let's move on. Solve. 3 equals log 4 of x plus log 4 of x minus 12. Okay, Catalina, any thoughts on how I go about solving? Yes, which property would be good to use here? Do you remember which one it was on Ben's list? Or you just think that there's one on Ben's list that would be useful here? Okay, all right, yes? So you're saying this is an example of the first property he wrote on the board, the product property. Where you see two logs joined with addition, you could rewrite them how, Catalina? Right, one log joined with multiplication. 3 equals log base 4 of x times x times minus 12. Great. So I guess if I were to say something here, I want to condense to 1 log first. Okay? Now what do we do? Mr. Rayo? Don't know. I feel queasy. Kaylin, can you help him out? Wow. Getting nervous, Zach. I would like it if someone suggested the use of a relatively new verb in their life. Yes? Exponentiate. I'm going to exponentiate on both sides. Exponentiating the last of the properties on Ben's list, the one I provided, is 4 raised to the log base 4. These are inverses and undo each other. This is how I solve a log equation. I need to exponentiate. In exponential equations, I would have to take the log of both sides, or the ln of both sides. But with log functions, I have to exponentiate to free the prisoners from behind. Don't forget, this is 4 to the third power, not 4 times 3. So we have 64 equals x squared minus 12x. Okay, so 0 equals x squared minus 12x minus 64. Does it factor, Brendan? Great. So Stephanie, what are our solutions? Okay. And what do you think about that? Kaylin? I don't have any feelings about that, Mr. Kukla. I've reserved my feelings for that puma that I saw running across the street this morning. I saw one. First time in 26 years of driving up Bear Canyon. It wasn't a coyote that ran across the street. It had big, powerful legs and a very different shaped head. Mm-hmm. I wouldn't want my dog outside. Oh, maybe it was a mountain lion. Yeah, it was definitely, I thought bobcat first, and I said, no, bobcat would be small. This is not small. Yeah, no, this looked like bigger than coyote. Yeah, well, I mean, 26 years of looking, dude, before I got one. Okay, so yeah, I got a problem with this answer, even though I saw the big quadruped today. Oh, Megan. Remember, if I go back to the original problem, I can't take the log of 0. I can't take the log of a negative. So I can't put in a 0 here. I can't put in a 0 here. I could put a 16 into these. Those work. But these are must-check problems. They're must-check problems because log has a restricted domain. Every time you solve a log equation, you need to go back and check to see that those numbers work. Please don't be prejudiced against negative numbers. Just because they're negative doesn't mean they're always going to be the ones that get thrown away. The negative ones could be the ones that work, and the positive ones could be the ones you need to throw away. Okay, so you really need to check both answers. Hey, Kaylin, any questions about that? Okay. So on your whiteboards, will you do this problem for me? Log base 2 of, no, log base 8 of 2 plus log base 8 of 4x squared equals 1. You did it. I'm going to do it now. Five, four, three, two. Chloe, is this a must check or an ought check problem? I must check it because it's a log. 1. Yeah, I see some people with this, and I have some people with plus and minus 1. So how do we adjudicate this? Well, you know, if you're not sure, you can always pull out a calculator and say, hey, I was wondering about log of, log of, what was the original question? Log base 8 of 2. Yeah. So I'm going to have to do that as log 2 using the change of base formula. Oh, no, I don't. Ha 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 ha. Do I? Do I have to? Yes, I have to. Okay. Log 2 of log 8 plus log, was it 4x squared? 4x squared Gesundheit divided by log 8, change of base formula. And then on the other side of the equal sign, we have 1. Zoom 6. Did this log have a restricted domain, Kaylin? It's graphed in blue. No. 2 points of intersection. How come this time -1 worked? Yes, Chloe? Because of this squaring. The squaring was part of the original problem. Now, if there was some squaring that happened after I used the product property, then no, sorry, that comes later. But this squaring, this works just fine. Any questions on solving? Okay. How about this one? ln x minus 1 minus 2 equals ln of x plus y. I'd like you to solve for x. Please solve for x. Thank you. Hot diggity. That's great. Now exponentiate. Something's missing. You don't have enough x's. Oh, okay. Sure, I like that. Yeah, no, it's all good. Hey, move all the logs to one side. How's it going? That's great. Now exponentiate. This is great, but yes, not each piece. What's the matter? Where? You're trying to get x by itself, so why don't you just divide by stuff that's attached to x? How's it going? I like that. I like that. Where did the x go? Just x. And then move all the x's onto the left side. How's it going, Johnny? Mr. Kukla, I felt like I used to know some algebra. Why do you give me these problems that make me feel bad? Well, because, you know, it's good to think. Okay. Perhaps, Johnny, you can give me the first step. So can I move the not ln over there? Okay. Nice. Where do we go from there, Catalina? So you're using that quotient property. Good job condensing into one log on the left-hand side. Now some people got stuck at this point. What would you recommend to them, Stephanie? Exponentiate. Thank you, exponentiate. You saved the day. Okay, so we know that exponentiating these undo each other. We have x minus 1 over x equals e to the y plus 2. Notice it's not e to the y plus e to the 2. That's curiously inventive math. Don't do that. All of this stuff is my exponent when I exponentiate. Good. Where do you go from there? Where do you go from there? Mr. Rayo. Thank you, Mr. Rayo. I have asked you many questions today, and finally I have one that feels comfortable. Y plus 2. Good. And then where do I go, Megan? Add 1. Okay. X equals x e to the y plus 2 plus 1. Yes, Morgan? And I think that's what she wanted to do too. She was just getting them on the other side, which is why your answer, like Sam's earlier, would have completely different SIGNs everywhere than the answer we're going to have up on the board in a minute. Sarah, what next? No, I just got the one over there. Morgan, you seem to be making a successful argument without saying anything for your choice. Okay. Sarah, why did I want the x's all on one side? So I could factor an x out. 1 minus e to the y plus 2. And then that final step that people forget to do, yes? So x equals 1 over 1 minus e to the y plus 2, which looks distinctly logistic to me. Okay, any questions about this process? It's just algebra, doesn't bite. Okay. Let's take a moment to talk about some graphing stuff. I heard that. Log base b of x equals y. The reference points are Darity. I can't plug a negative into a log. Very nice. And what's the thing that's missing here that I would like to make sure isn't missing? She's going to suffer skin failure if you don't call on her. Where's the vertical asymptote, Darity? X equals 0. Great. Okay. So if I have log base 2 of x minus 3 plus 1, does that 2 do anything? Julian? B is the base. And so the only thing it does is plug in for my b's. 1/2, -1, 1, 0, 2, 1. Great. And then how do I carry out these transformations? Yes. Add 3 to all the x's, including x equals 0. So I'll add 3 to the x's. And do we have a y transformation? So my final points then, 3.5, 0, 4, 1, 5, 2, and we have a vertical asymptote at x equals 3. X equals 3, swoosh, 3.5, 0, 4, 1, and 5, 2. Any questions about graphing this? Ben? I just asked him if he had any questions about graphing this. I'm sure Ben wouldn't be obstreperous like that. Okay, great. On your whiteboards then, will you graph this one? -2 log base 3, 4x plus 1 plus 5. We're graphing this one. 5. Four, 3. Megan, where's the vertical asymptote? Negative 1/4. Good. And where's the point closest? Where's our new reference point closest to that vertical asymptote going to be, Zach? Negative 167. And then the middle of our 3 points, Chloe? I like the 0 part. Elena? 0, positive 5. Okay. And then our third point, Stephanie? I also got 1/2 3, and my graph looks like this. Do you have a question, Johnny?
I don't know what I'm doing.
Take a look. So when I looked at those transformations, I saw a 4 and a 1 for x transformations, and a negative 2 and a 5 for y transformations. Okay. Any questions on this one? Would we be ready for a pop quiz on this tomorrow? Yes? I'm just wondering. Okay, cool. Exponential. Because exponentials and logs are inverses of each other. Switch, switch, switch. Okay, great. This is mislabeled as exponential word problems because, as you notice, that 1a is linear, not exponential, and 2 isn't exponential at all. I mean, it's just even and odd and symmetry and stuff like that. So, yeah, this is a lot of, oh, look, there's a logistic problem at the bottom. So this isn't your homework. This is your in-class work. Your homework is bookwork assignment. Bookwork assignment. This, though, needs to be finished. So get to work. I recommend working with a partner, and I recommend starting with number 2. I thought last night was 14. Oh, let me check. Okay. Well, I'm still looking. There we go. Yesterday we did 13. Tonight is 14. This is the More Solving Word Problems worksheet in class. That's the one we got a long time ago. Yes. 1A or B? Oh, well, B and C are exponential, but A is linear because it's 10 grams per day. It's a fixed amount per day. If it were exponential, it would be 10 grams and then 20 grams and then 40 grams. Call me over if you have any questions that you and your partner are stuck with. What? If you divvy up the work, you still have to show all the work on yours. And some people choose that option, Grant. Yes, but my suggestion was to start with number 2 because number 1 is often easier for people than number 2. If you had to finish this, say, on your own, you would have a happier time, generally speaking, doing number 1 by yourself and not number 2 by yourself. I think maybe 5 is a good one to do with a friend also because it's logistic-y. Do I want what? Let's see. When do I want this by? I'll take questions on it tomorrow with the homework, and it'll be due the day after tomorrow. along the, good. Origin symmetry. Plug in negative x and negative y. Yeah, yeah, yeah. That was a good O. Like, I think you owned it with that O. But I think also you might be liable to forget it, so you might want to note it somewhere. Yeah. Hi, what's up? Yeah. Hmm. And then G minus that, so 27 minus 7 squared. Yes. Hmm. Good. Hmm.